with respect to our training, because our training is going to happen around rotorcraft. Okay. Okay, so let's see what is rotorcraft operations and aerodynamics. We are already 5:15, so 45 minutes are there. We can complete the topic. Okay, so just a small couple of slides on a history perspective, since we are doing rotorcraft aerodynamics. And so, do you know when was the first UAE was used or introduced? So it was in 1849, August 22nd, 1849. So basically, Austrians, they used balloons, okay, helium powered balloons or hydrogen powered balloons, for attacking Italian city of Venice, okay, with unmanned balloons. So they will actually fill the balloon with the hot air or maybe helium gas. It will rise, and they will attach the explosive around that basket, okay, and that basket will release after, they know after particular time the balloon will fly up to certain distance. After reaching at certain distance and time, automatically it will trigger and launch those explosives. Okay, so it will keep on dropping at regular intervals. Okay, that is what was they planned. So this was the first application of unmanned vehicle, okay, aerial vehicle. So though this was not successful, this was actually also used during World War II by Japan. Okay, from Japan they used to launch such kind of balloons, and they used to go reach. They thought that it will reach the western coast of America. Okay, the Las Vegas, California, and all those locations. But I would say, fortunately or unfortunately, none of those drones or those balloons basically reach the lands. Okay, so almost 1,000 plus of such balloons were made and sent. Okay, but only one balloon reached the land, and still no injury was happened, even that one particular balloon. Okay, so that is only one incident where they are able to rest. All the balloons they lost in the Pacific Ocean, because you see the distance from Japan to America, it's very huge distance. Okay, the balloon has to sustain that much distance. It should fly, and then it is on its flying. You do not have any control. You are just rising and leaving it. Because of the air motion, what is happening on the sea, the balloon is going. So balloon can go in any direction. You cannot have a control on it. So none of the balloons reached actually the land. Only one incident where they are able to get this particular drone or UAE or the balloon reach the land. Okay. Apart from, there is no success of this. Okay. Now, who is the father of the drones? It's Dr. Abraham Karim. He was born in Baghdad, that is in Iraq. Later moved to Israel in 1951. He was aeronautical engineer from Techon, Israel Institute of Technology. First, he built the drone during Israeli Air Force War, okay, Yom Kippur. In 1970, he migrated to United States. He founded there a company by name Leading Systems and started manufacturing the first drone, what is called as Albatross. Okay, later on, this drone Albatross was acquired by the US force, okay, and it was renamed as Predator. So now whatever the drone you see, Predator, that drone is being made by Mr. Dr. Abraham Karim, and that's why he has been given the title of father of drones. Okay, this is just a small history about knowing about it. This is nothing to do with your training, but this is what DGCA that you people should aware of the history of drones. I mean, if you talk about history, you will take 1 hour to talk about. There are so many things to talk about on the history part also. Okay, I mean, how during the World War I and II the drones were developed, or the aircrafts were developed which were flown remotely, and lot of things were there and all the things. Okay, so almost first 100 years from the first flight of Wright brothers till 2000 of year, that first 100 years, drones, these remote pilot aircraft, were predominantly used by only defense. Okay, only by armed forces. There was no usage of civilian in the drones. The civilian part of the drone started from 2000 onwards. So that is the time when people, made these popular kind of drones, and then they attached camera for videography, photography, and all this. That's where the first use of real drone came for a civilian purpose. Okay, and there where the people saw the potential use of drones. So first 10 years, people were just making and doing it for fun, recreational activities, and all that kind of thing. No real thing. Like even if you see in India also, the first drones were made. I think Shubham must be knowing about their history, right? The students from IIT Bombay only made those drones, which were.
Yeah, in fact, fun fact, my professor was the one who was involved in that time.
Oh, great.
So we did not get propellers. So propellers also we made in house.
Correct. So people used to make in-house propellers and all that things. Even the motors you can build. See, in fact, you can build most of the components on your own of the drone. See, in a drone, what is there? First is the frame. It can be anything. It could be wooden made. It could be aluminum made, or it can be any material you can use. Okay, lightweight material. Then you need motors. Okay, motors you can make. Propellers you can make. Then it needs power, and then it needs basic electronics. Okay, I am talking in a very basic level of starting the drone. See, advanced version will come that when you have a high type of avionics, electronic circuit, best quality of motors, best quality of propellers, best quality of carbon structured frames, and all that things. But to begin with, you can start. Okay, so we normally, like I have seen people making a small BLD, small generic motors they use. They use ice cream popsicle sticks to fit those motors, and then small propellers and all that. People have made drones using a small what is that ESP32 controller also, using those devices also, and there people have made drones. Even small kids have made those drones. So making drone is not difficult. It's all how you want to use, but more stability will bring only when you have a control on controlling the motions of the propellers and making it more stable. Okay, so testing and configuring and fine tuning is what is important when you make a stable drone. Okay, so what is the basic drone overview? Types of multi-rotor drones, quadcopter, anatomy and terminology, and inner electronics of drone and applications. Okay, so there are a lot of slides where we talk more about in detail about each component, because this is the drone what we are going to fly. This type of drone, I mean not this drone, this type of drone, that is quadcopter or hexacopter. So we will be actually flying a hexacopter drones. Okay, not only quadcopter, but actually we will be flying hexacopter drone. Okay, so what is drone? Drone is nothing but aerial, ground or underwater vehicle without a human pilot on board. So that is the definition of unmanned aerial vehicle. Okay, without a human pilot on board. It is known as unmanned aerial vehicle or remotely piloted vehicle. Okay, the entire system, like here this is only a vehicle. This is only a vehicle. Okay, so that's why it is RPV. Okay, RPV vehicle. But when you have a pilot or when you have a system, okay, the entire system known as unmanned aircraft system. So a lot of time people might ask you the question, what is the difference between UAV and UAS? So a lot of people, they don't know we drone hai. Both are drones only. It's not like that. UAV means vehicle. We are talking about drone. But when you are talking about UAS means entire system, right from the drone, the remote control, the ground station, the pilot, all these makes as a system, okay. So whether you call it as UAS, unmanned aircraft system, or RPAS, okay, remotely piloted aircraft system. Okay, that is what we are saying. RPAS, RPA plus ground control station. Okay, that's why it is called RPAS. Okay, so how does drone flies? It may be remotely controlled by a human operator. So you can see here, a person is flying a drone and he has a remote control. So this is RPAS, remotely piloted aircraft system. Whereas flying autonomously with the help of onboard command. This is autonomous UAV or flying. So you are just feeding the flight plan and everything, and you are just saying execute. That's it. You are not actually flying the drone. Okay, you are just monitoring and seeing it. In case of any kind of emergency, you can take over and manually manage the drone. Okay, whereas most of the operation is conducted autonomously. So either both of ways, either you can remotely fly on the drones or you can autonomously fly the drone. Okay, so there are multi-rotor drones. Multi-rotor drones or rotorcraft with more than two motors, they are called as multi-rotors. Okay, further classified based on number of rotors. So normally you can see there are even number of drones. Okay, even number of rotors are stable drones. Normally single rotor is never stable, because you see helicopter is a single rotor, right? To stabilize, you have a tail rotor also is required. So technically, it is not a single rotor. So you have another rotor which is flying, rotating on the tail portion to counteract its opposite direction motion. Similarly, tricopter are also not successful. So whenever you have an odd number of motors, it is very difficult to manage and maneuver it. Okay, so normally quadcopter is the best configuration because it has four. So four and more. So 4, 6, 8, 10, 12, whatever the odd number, sorry, even number is always a stable. Okay, so why we'll have a more amount of propeller? To give you more power to thrust ratio, right? Why hexacopters are always, I mean the agriculture drones are made hexacopter, because that tank 10 kg का जो tank है, 10 12 kg 16 kg का जो tank है, that weight needs to be pulled. How that weight will be pulled? By adding more number of propellers. Okay, that's why you will see agriculture drones are hexacopters, whereas surveillance drones will be always quadcopter, because their weight is very less. Hardly a small camera of like, let's say 1 kg or 2 kg का रहेगा. So not much weight is required. So quadcopter can easily manage. But अगर बड़ा drones है, जैसे air taxi भी है, air taxi में you will see octocopter or even 10 these things are also there. 10 to 12 blades will be also there, depending upon the weight to ratio will be there. Okay, depending upon the motor propellers would be there. Okay, so pros and cons we have already seen it. Vertical and landing, hovering capability, operation from a confined space. This is one of the important properties or the pros of the drones. Okay, so drones can, like drone cannot go inside the windmill, drones cannot go inside the ship, or drones cannot go inside the drones means I am talking about fixed wing. Okay, whereas the multi-rotor drone, those smaller drones can go inside those confined spaces. Okay, that is the advantage of multi-rotor drones. But what are the cons? Limited endurance capacity compared to fixed wing, less chance of recovery in case of motor failure. Okay, cannot perform high altitude long endurance. It cannot fly beyond like 20,000 feet and all that kind of thing. Multi-rotor cannot go on that thing. So they can go maximum 1,000, 2,000 feet, not beyond that. Okay, but then there you have to compromise on the endurance capacity, because endurance will keep on reducing, because the more higher you fly, more power it will be taking, your endurance will reduce further. Okay, that's why you see agriculture drones are limited only to 100 feet, even though the range of green zone is 400 feet. Still, agricultural drones are limited to fly only up to 90 to 100 feet only, because say your crop is not going to be higher than 10 to 12 feet or 15 feet max, right? Right, Soham?
Yes, sir.
Right, like maximum height किसका होगा? आपका सुगर केन फील्ड का ही होगा, right? उससे ज़्यादा
Maximum 18 to 20 feet.
18 to 20 feet. या कोई आपको ट्री पे, कोई पे किसी पे करना है, लेकिन मैंगो ट्रीज है जिसका हाइट ज्यादा भी हो सकता है, तो उस पे अगर स्प्रे करना है तो मे बी हाइट, बट देन नॉट 100 फीट के ऊपर तो नहीं होगा, राइट? इतना बड़ा ट्री तो नहीं होगा.
Yes, sir.
Okay, so let's see what is the anatomy of the quadcopter. I mean, if you want to build a quadcopter, you can have this frame. This is called 450 frame. Okay, you can have the motors, propellers, and then you can have this landing gear, and then you can have a flight controller. Various flight controllers are available for building a test drone. The KK215 वाला भी है, DGA NASA भी है, Pixoc है, R2 Pilot है. I mean, there are various flight controllers are available. Then you have motors from T-Wing, Hobby, T motor है, Hobby Wing है, and then there are the third party motors are also available. Similarly, along with the motor, you can get matching propellers also. Okay, so you can't just take motor and decide whatever propellers. So a lot of time motor will define what kind of propellers are being tested and suited for this particular motor motions. Okay, similarly with the motor, you have to have a matching or required ESC, that is electronic speed control. It's nothing but it's a regulator which controls the speed of the motor as required for the motions. Okay, so that ESC will be a circuit. Then you can have a payload like a camera with a gimbal, and then you can have FPV from seeing where your drone is flying. Okay, and then the power pack, which we called as a battery pack. You can have a battery of different sizes: 5,000 mAh, 10,000 mAh, 20,000 mAh, 30,000 mAh, depending upon the way you design the drone. Okay, so this is all about the inside parts. We will see this practically also, these components, when we go to Igatpuri. So if you see detail about each, so propeller which converts the rotational motion to thrust. So there could be two types of propellers. One is pusher motor and pusher propellers and puller propellers. So depending upon the orientation or the way the propellers are. So normally, as of now, don't think about pusher and puller. Think about clockwise or counterclockwise. So if you see these propellers over here, one is clockwise, one is anti-clockwise or counterclockwise. So basically, the propellers are designed based on Bernoulli principle and operate on Newton's third law. Okay, so the propellers, if you see here, they will be having a shape of like a airfoil. Okay, so the blades are designed like an airfoil, and they will having a leading edge and a trailing edge. Okay, so based on their leading and trailing edge, their motion is defined either clockwise or counterclockwise. Okay, so we will see this practically in our store when we open our drones, when we take the drones from the boxes and get them ready for day 4 flight. Similarly, motors, they are used to rotate the propellers. Brushless DC motors, highly efficient and long lasting. Before advancement of even drones are more famous because of these Bale DC motors, because prior to that people were using normal DC motors. Okay, so the normal DC motors are not efficient because of the friction, the carbon, what is that, brushes, what is touches, it doesn't give you that efficiency and all that, and they used to worn out and all that things, and they not give that much speed what the brushless DC motor has there. Here now your armature is fixed, your outer side rim where the magnets are there, it is moving. Okay, so there is no movement of electrical coils over here. It's actually the magnets which are moving around the coil. Okay, so the key parameter to focus when you're looking at the motors, the motor speed, the thrust value, compatible ESC, compatible battery. So out of this, see, speed is not matter for me. What compatible ESC is secondary for me. What compatible battery is. When I am designing a drone, what I will see is how much thrust it can generate. For example, a motor can give me a thrust of picking a weight of 10 kg. So 4 motors when I connect, so 4 into 10 will give me a capacity to take a weight of 40 kg. That is what more important. Then once I know that my drone is capable of picking 40 kg, I will decide, okay, what ESC is compatible with it, what propeller is used, what battery is required based on my endurance capacity. All that is secondary. So when I am designing a drone, first thing I will decide the motor which I am used and what thrust value I am getting it. Clear? Anything you want to add? Okay, so as you see the motor, basically the motor speed can be controlled by electronic speed controller. So normally on the motor there will be a rating. Okay, what is that? Ampere rating is given. What ampere ESC you have to use. Okay, so like for example, motor is defined that you can use 25 amperes. Okay, for example, I'm just giving for example. Okay, so when you say 25 amperes, that is what the basic or bare minimum you have to use. Okay, but then if you are using 25 ampere motor ke liye 25 ampere ka AC, so at a full speed your ESC will become very very hot. Okay, possibility of that ESC getting burned off is also possibility. So normally when you are having a motor capacity of let's say 25 amperes of power, it is pulling up. Okay, so that scenario you have to use ESC of little bit higher capacity. So agar 25 amperes ka motor hai which is generating taking up the power, you normally use ESC maybe of 30 amperes or maybe 35 amperes. एकदम ज्यादा भी यूज मत करना कि 25 का मोटर है और 50 amperes का ESC यूज किया. That is no use because 30 amperes का ESC and 50 amperes the cost will be almost double. Okay, so you will be wasting unnecessary, no use, you will be wasting money over there and you will not be utilizing ESC what meant for it is. Okay, so जहाँ पे आपको minimum like if it is 25, use 5 or 10 का difference. Don't give much of difference like 25 का तो 50 का 60 का 80 का एम्पियर का ESC मत यूज करो. Okay, use bare minimum required. Okay, maybe 5%, 10% here and there. So basically these ESCs can control the motion of the motors. Okay, so there are 3 wires coming from the ESC. You can interchange But in an enterprise drone, that is not been advisable, because your motor orientation is been defined on the motor itself. On a normal small cheaper motor where the orientation is not mentioned, there you can change the direction of a motor by interchanging the wires. But in an enterprise drones, or the drones which are using enterprise class motors, high quality motors, on that motors the marking is there whether this is a motor clockwise or anti-clockwise. If you change the polarity, it will work, but it will not work efficiently. Okay, that's why it is not advisable in enterprise class drones. Okay, this acts as a dynamic brake, also battery eliminating circuit for powering flight controllers and receivers and other things. Also, like ESC has lot of other connections and you can power it, because it is a stabilized power. Because we are drawing, because if you see on the right side there are two wires only, red and black. This is nothing but this is just drawing the raw power. Okay, but electronic speed controller will be very stable circuit. Okay, it will be like battery eliminating circuit for powering flight controllers and receivers. I mean, where you need a very good source of power. Okay, stable power. Okay, there should not be spikes in your power and all, which can damage your electronic devices. So basically ESC protects all your components from that kind of surge. Okay, then you have a flight controller, as we said earlier, autopilot. That's the brain of the unmanned aircraft system, helps in flight stabilization, navigation and fail-safe redundancy. Okay, this fail-safe redundancy or navigation is very important, because that is where actually it will control your motion. It will control your drone in emergency situations. Okay, the most common flight controllers developers are ROTOPilot. So maximum worldwide, the drones which uses the flight controllers are from ROTOPilots. Then we have some from DJIs. Then there are a lot of other OEMs are also available who actually make custom flight controllers. Like right now in India, PDRL, there is a company, Nasik-based company, who has developed similar to ROTOPilot a flight controller also. It is almost a replica of ROTOPilot. So if you see any flight controller, it is the basics from the ROTOPilot what has been taken. Okay, so looking at the ROTOPilot, you can develop your own flight controller also. Okay, so a lot of people, Indian companies are now actually into this. That I can tell you at least 5 to 10 companies are there who are actually working on developing the Indian based flight controller also. Okay, now airframe. Airframe is nothing but it consists of housing enclosing the electronics, motor booms and platform. Okay, for putting up your flight controllers and other battery and all that things. Okay, it comes in a different configuration for quadcopter. Either it can be H shape, X shape, it can be plus shape, or also can be hybrid. Hybrid means it can be H भी दिखता है, X भी दिखता है, something like that. Okay, then we call it as a hybrid. Okay, normally it is not like this is H, this is X, this is plus. But if you see here, little bit, they are little bit having angles. It could be H, it can be X. So we do not know what it's to call. So people call it as H hybrid or hybrid configuration. Okay, so that's the airframe. So they can be, this airframe can be a normal aluminum grade, good quality aluminum grade, or it could be some other material also, or can be carbon fiber also. Okay, now battery pack. Battery pack is nothing but power plant of UAV. Okay, so unmanned aircraft vehicle. They are rechargeable LiPo or lithium ion, which are widely used. High energy density compared to conventional batteries. Normal those AA or AAA cells, compared to that, this has very high energy density. Vary by discharge rate, capacity and voltage. So whenever you are seeing the battery, normally you see the capacity, okay, which is very important. So 5000 mAh battery may give you around 8 to 10 minutes of flight time, whereas if you double the power, it may give you up to 12 to 15 minutes. Okay, it will not exactly double. 5000 के जगह पे आपने 10,000 डाल दिया, so अगर 5000 is giving you 8 minutes, doesn't means that 10,000 will give you 16 minutes, because the weight of the battery will increase, which will reduce the endurance capacity of the drone also. So not exactly double, but at least 80% of what it. So that's why I've said 12 to 15%. So 16% नहीं होगा, 16 minutes नहीं होगा. Okay, like that. Then we have a camera gimbal used to mount the payload. helps in stabilization, pan control, tail control, and all the things. If you do not have a camera gimbal, you can have a fixed camera. Like surveillance में कभी-कभी fixed camera भी लगाना पड़ता है horizontally. Okay, sorry, and it is taking horizontal photos of the land. So in that scenario, you may not use camera gimbal and all, but then you will sometimes you will encounter vibrations, all that things and all that things. So normally people use camera gimbal even though you are taking a horizontal photographs also. Okay, so basically it helps in stabilizations. Okay, so your videos or your images will not have blurred images and all the things. It will stabilize, completely stabilize, even though drone is flying or moving and all the things. It will stabilize, and then by having a gimbal, you have an option. Like when we were doing power line tower monitoring activities, so the power line tower is a vertical. I mean, it's like a pyramid structure, right? So base पे आपका बड़ा रहता है, ऊपर जाता है छोटा. So every time you have to adjust the angle of camera. Okay, so pan and tilt आपको करना पड़ता था, especially tilt motions. Okay, so that needs to be fit. As you go up and higher, you have to fix your lens. So as you go down, you have to tilt your camera at the angle of your tower. Okay, so based on that, the camera gimbal was used. Landing truss. These are the legs that drone rests on when it is landing or grounded. Okay, comes in different shapes and sizes. So depending upon different drones, there will be a different landing truss. Again, these landing truss are foldable, mechanizable. Some are even hydraulics are there also. Spring loaded are also there available. So different types of landing truss or landing gears are available. Okay. Then your radio transmitter and receiver. As I said earlier, radio controller transmit the input given by pilot to the receiver via 2.5 gigahertz. So that is ultra high frequency range, what I said, right? So communication link preferred frequency in this device is 2.4 gigahertz because of max frequency. You can set your own frequency also. You don't want to use 2.4, you want to communicate on 2.2, you can do that also. Okay, if you want to change, you can customize your own frequency communication. But then lot of devices you need to modify accordingly to it. So standardized is 2.4 gigahertz. So all your telemetry devices are being trained or been configured to use on 2.4 gigahertz. Similarly, for video transmission, your FPVs and your GCS on whatever the images or the videos what you see on this, it operates on 5.8 gigahertz because that is the frequency on which it gives a noise-free and best quality video signal. So a lot of people used to ask like, why 2.4 only, why 5.8 only, why not 5.10, all the thing. So these are the frequency which have been tested by the people, the researchers, and they have specified that these are the best frequency to use for basically maximum efficiency in communication link, and 5.8 gigahertz for best of noise free and best quality video signals. Telemetry, again there are telemetry devices also used. You can connect your ground control station and the drone side. So air end, which is called connected to drone, and the ground end is connected to the GCS controller. Okay, provides crucial telemetry data like altitude, distance, speed, wind, speed, etc. So dynamic updation of flight plans and change in the missions. So during that time you have to use these kind of telemetry devices. Okay, so there is a separate component which comes for a telemetry connectivities. Okay, now drone will be having such things like you would have seen DJI drones, even agriculture drones. They have some kind of orientation or planning. So you need to know what is the front side of your drone, what is the back side of your drone, what is the left and right of your drone. So there will be some markings on it or this, or there might be some kind of LEDs or strobe lights are there on the drones to identify the front side and back side. But these are only visual markings. But even you as a pilot, by looking at the drone, you should know what is the front and what is the back. So this I will park as of now. I do want to show this you practically. Okay, so I will be showing you in the store as well as on the field also. Okay, so we'll be demonstrating in the store as well as in the field. I will be asking you to identify the orientation of the drone. Okay, then we have ADSB. ADSB now, as I said in the early morning, that type certified ADSB is not being implemented because that is an automatic dependent surveillance broadcast module is there which determines the aircraft position. Okay, via satellite navigation, and periodically broadcast it's enabled to be tracked. So basically it is a device which actually broadcasts the information about the aircraft, I mean the aeroplane rotorcraft or hybrid. So this will come when we have BWL. This will become mandatory when we have a BWLS rules and regulation comes in. Okay, so real-time ADSP is used now for air traffic control, weather and flight information services. So normally ADSB is already there in the all the commercial aircrafts and commercial or civil airlines. Okay, so everybody has this. The same thing is need to be applied, but in an aircraft it's a very complex and big device, whereas in a drone we need to have a very small module. But okay, so there are a lot of testing, lot of development is also happening into this segment also. Okay, so we need now, if you need to have a ADSB implemented, I'm talking about BVLOS, I'm talking about RTR, but then you need another component which is called as UTM, unmanned traffic management system. That means you need to have a system like how you have a ATC, because your ATC are not going to monitor the drone operations, because there will be more number of drones than the aircraft which are flying. So there has to be a separate ecosystem needs to be set up, a separate NOC or separate ETC for drones would be required. Okay, then only this will become practical. So you need to have so much things of ecosystem to be set up, then only it will be able to function. Okay, then only this will be useful. There may no point, like this module might be costing like 80,000, 20,000 or 40,000 rupees. You know, this will unnecessarily overload the cost when you are not going to use this functionality itself. Okay, that's why as of now none of the type certified has this module. Okay, that's why the DGC is also not making mandatory to deploy, because that ecosystem is not there. Once you have the ecosystem, once you have the procedure to operate and procedure to use, then only it is viable to have this kind of components on your drones. Even the strobe lights are not mandatory. Okay, right now drone manufacturers, they are putting, okay, the motors are been designed in such a way that it has basically strobe light. Basically क्या होता है, strobe light ऐड करने से आपका बैटरी का पावर खा जाता है और कुछ नहीं होता है. Okay, as of now, because you are flying in a visual line of sight, you are flying in a daytime, तो आपका strobe lights तो आपका यूज ही नहीं हो रहा है. It is unnecessary blinking and taking the power. Though it is a LEDs and all, not taking much of the power, but still it is taking some power, right? At least 1% to ले रहा है, 0.5% तो ले रहा है ना. So that is what I am just saying. Okay, so depending upon how many strobe lights, what like somebody puts some lighting and all that things, they do lot of things. Okay, so depending on it. Then let's see about the electronics, inner electronics of the drone. Then we, as we said, the flight controller, it has its flight controller. There is a microcontroller in it, okay, which collects all the informations or measurements from all its sensors, tells the motor what to do, and based on the both sensor and the user inputs, the motor speed is defined. Often connected to the ground station through radio or connected to the pilot through the control link. Like normally, whatever the RC what we are using, the RC is actually the remote control what we are using is a GCS, inbuilt GCS. So it has its own screen on the RC itself. Okay, so you can see and see all the parameters. So everything is available on this. You don't require a separate GCS or separate laptop to be set up to see the operations and all this. So all the altitude, temperature, everything is available on your small screen. Okay, there is a component called altitude and heading reference system which tells aircraft where it is moving. So it is basically based on your motions, your roll and pitch, it will give inputs to the flight controller, and it will store its motion, like how far it has moved, how far, how left, how right, how up and down it has moved. Okay, so all that information will be coming from altitude and heading reference system. Okay, then you have another important component which is called IMU also. Okay, inertial measurement unit. This is basically a device which actually monitors a body specific force, angular rate. Also it has a magnetometer which actually sends how much magnetic radiations are affecting on the drone or having on the drone. Then it has accelerometer, gyroscope, compass. All these components are available in IMU. So IMU is a very important. Before people using GPS, people were using IMU. Okay, and even today the IMU is also there, because in case of GPS failure, IMU can help you to manage and control the drones. Okay, so that's why you will always have IMU as well as GPS. GPS will give you more accurate position of the drone with respect to the latitude, longitude and the altitude. Okay, so these three things will be available from the GPS, but in case of failure of GPS, IMU will be helpful, because it will be also measuring the same parameters along with. So that is a built-in redundancy is there. So normally if you see in a higher class drones, the flight controllers like Pixoc का orange cube है या flight white cube है, this will be having multiple IMUs. Either it could be having 1 or 2 or 3 IMUs. Even you can have 1 or 2 GPS also. The more redundance you build, the more stable drone will be there. Okay, so that's why how the devices are being built. Okay, so when in case of GPS failure, basically GPS will come more practical application will be in BVLS conditions, because that time we will have to know what is the latitude and longitude of the drone, okay, which will be communicating when we are flying under BVLS conditions. Okay, in case of failure of GPS, the GPS module will automatically failure. In that case, the flight controller will automatically trigger RTH or RTL, okay, return to home or return to launch position. Okay, so this is capability of communication or battery failsafe. So depending upon various requirement, we'll see this in more detail about the emergency procedure topic in the module tomorrow, where we will be discussing different scenarios, what could go wrong, and where we need to configure the mechanism so that we can safeguard our drone from crashing. Right? Then we have a power module. So if you see, there is a battery connector, right? From the battery side, it is only 2 wires, positive and negative is coming. But then when you are powering the ESC or powering the motor, you need to give a very stable power or regulated power. Okay, so it is an input connected to the battery, output is connected to power distribution. Now, power distribution board is just a board. Okay, so where you have to solder 4 ESCs, 4 motors, and other components, all the things you can solder on power distribution board. It is just a PCB board on which all these components are soldered. But there has to be a component which like there will be a regulator which will be monitoring the battery levels. There would be multi-cell, like normally we are using 6-cell battery. So it has to measure all the 6 cells and give inputs to the flight controller what is the current status of the battery. Okay, so basically this component is there which actually monitors and manages. This is the very basic level, but there are advanced level battery management cables and softwares are also available to monitor the battery levels. Okay, so higher quality of drones, enterprise quality of drones will have a like in a battery itself there will be a battery management system built in. Okay, which will be giving inputs to the flight controller about its status. Okay, so that's why some batteries are very raw batteries, like we are using raw batteries for our drones, whereas there could be a like DJI agriculture drones, they are using very high-end battery which is having its own built-in power management systems. Okay, so as I talked about power distribution board, PDB, it's nothing but receives power from battery and distributes the input to multiple ESCs. So अगर 4 ESC है तो 4 कनेक्टर रहेंगे, 6 ESCs रहेंगे तो 6 connectors रहेंगे for hexacopters. Can also power different accessories attached to the drone like HD camera, LED lights, or maybe gimbal also. You can draw a power from the gimbal for gimbal also from the ESC and all. Okay, so we are just at the couple of slides left now, and we have left 10 minutes also. So what are the application of drones in various sectors? As you said, we said in the morning, it can be used in agriculture, it can be used in forest and wildlife monitoring, urban development, healthcare, traffic management, homeland security, disaster management, mining. So these are some primarily currently where they have been extensively used of drones. Okay, but there are new industries, new sectors are also coming up where the drones are being utilized regularly. Okay, so you can see these are some business ideas for UAE industry. Those people who are interested, like you can start up your aerial photography or videography. A lot of students who have done courses from us who are already into aerial photography or videography or who wanted to start also, they have been benefited out of this course. Okay, commercial inspection service. There are 2 students of mine who actually are trying to build a commercial inspection services. So they have wanted to build a surveillance drones which can be used for surveillance activity or inspection activities within the city and within the building premises and all the things. Again, surveying and mapping series, logistics I talked about, the delivery of delivery drones, what we talked about. Then we have residential home inspections. This is also one of the important aspect of drone usage, where you cannot reach those locations or high rise or complex building structures and all the things where, like check the roofs, chimneys, siding, bricks and other structures, exterior damage inspection, all that can be done using the drones. Then as we have so many drones available, you may have to drone parts and repair. Like if you see, there are people using DJI drones, but there are one or two DJI drone repairers, okay, in city. So it's very very critical to have people take up as a drone technician. So that's why you see there are a lot of drone technician course also are getting developed and designed for the people to give a repair and change services also. Then there are advanced ideas, like couple of companies have started drone aerobatic shows or aerial advertisement. Even night shows have been getting organized by the drones using the swan technology and all that things. Okay, and advanced usage of UAEs like data analytics, engineering consultancy, SaaS-based firms, or UAE insurance also. Like insurance company also had able to generate more number of insurance, because you see there are almost like I would say how much uh, 30,000 plus drones would be there. So you need that much number of insurance. However, people are still, because see, DJI had not mentioned in future there might be a component where when you are registering your drone, DJI might, sorry, not DJI, the DGCA might ask you to input your insurance component. Like when we are registering for RPTO, they have asked us to give the insurance and the AMC of the drones. Okay, without that we will not got the authorization also. So for a normal people who are actually registering their drone, as of now DGCA is not asking for UAE insurance, but in near future that will become a mandatory. Like जैसे हम लोग RTO में, right, RTO में जाते तो कार का इंश्योरेंस या बाइक का इंश्योरेंस इज मैंडेटरी, और PUC is also mandatory. So same thing will become a mandatory feature for insurance part of the drone also. So this is also one of the good opportunities for people to cover up. Okay, so with that we complete our module about the fixed wing and rotorcraft also. So both aerodynamics and the last one which is remaining. I will not continue today on that topic because that's just hardly 10 slides. So we'll start tomorrow morning fresh. Okay, so we'll be meeting again tomorrow morning at 10 a.m. sharp and starting our sessions. We'll start with the hybrid aerodynamics and operations. Okay, so that will start. That is a small topic. Would have done it now also. If you want me to do it now, I can do it now. But if you want to wind up the today's session, I can wind up. What is your suggestion?